Hi, Ilya is here from Gamechanger Audio. Flew in from Riga this morning.
Hey.
Lovely to see you. We're looking at the Motor Synth MKII, which is
right.
the sort of second production run of your, frankly, quite bonkers synthesizer.
Yeah.
I mean, based on this, I mean, these are 8 moving part motors that are brushless DC motors?
Brushless DC motors, exactly, yeah.
And they were generating the sound that we just heard, right?
Exactly, like, to clear up any confusion, the name Motor Synth is exactly what it implies. So it's an electromechanical synthesizer, and the sound, like the most of the sound we just heard, for example, was created by these motor oscillators. So, for example, when I was just using the oscillator drift, you know, knob to make the little movement, it was actually achieved by warbling and like modulating the actual rotation speed of these motors. And so basically the whole idea for this concept is based on the natural and kind of this real quality that the motors bring to the game.
Yeah, it's got a really organic sound. So I guess 8 motors is 2 per voice, is it? So 2 oscillators per voice, so 4 voices.
So yeah, exactly, yeah. So there's 2 fully independent motor voices, so labeled here voice 1 and voice 2, and each one of them, both voices offer 4-note polyphony. So you can make a 4-note chord and, you know, have one voice do the upper register and the other voice do the lower register.
Right.
The motor oscillator is the kind of the star of the show, and we were first drawn to this idea simply as it's a kind of an interesting
thing, right? Yeah.
Kind of an engineering thing, exactly. Like these drone motors, they're so fast and responsive and durable and interesting that we can almost make music with them. That was the initial kind of spark. And then, you know...
And then you did.
And then we started experimenting more and more, and then eventually it was clear that we're going to make a synthesizer with motors. Yeah, we had this kind of like spark of inspiration, because that's what we do at Gamechanger Audio. The whole philosophy for the brand is to, you know, there's a lot of amazing classic instruments out there and lots of like these set ways of doing things. So why build those instruments again?
Right. Okay. Yeah. That makes a lot of sense.
We don't want to, for example, like we don't want to say that like this is a better oscillator or something like that.
It's just something
else.
It's
certainly not a better oscillator. It's a terrible oscillator from many points. Like from many points.
On paper.
Yeah. I mean, yeah. It took us a lot of years to make this oscillator work, and for it to be, you know, reliable, perfectly perfectly in tune and so on, but the result is that it undeniably produces a different sound.
Yeah, there's all sorts of really interesting fundamentals and harmonics. So what waveforms do they actually output? Is there a variety, or is it a fixed waveform output?
So each one of these 8 electromotors, I don't know if we can see that in the close-up shots, but each one of these electromotors is equipped with a tiny little electromagnetic inductor.
Right.
So these inductors, they're the size of you know, like a pea or a tic tac or something like that, and you can see them mounted on the boards next to each motor.
Yeah.
And what these inductors do, they act as magnetic pickups that collect the energy fluctuations caused by the motor's coils. When the motor's rotor starts moving, these electromagnetic like wound coils, they start passing by the inductor. It creates essentially a wub 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 wub, that kind of sound.
Yeah.
So, and this is the basic electromagnetic wave that can be produced by you know, by using an electromagnetic inductor. And this wave is labeled here with the symbol M.
So, as you can imagine, there's a lot to get through with this. This is a shorter edit for YouTube. There will be a longer format version of this on our Patreon, which you can get to right here. Right, okay.
Yeah. So this is the wave, like we're listening to one voice now. And I can also slightly alter the tone.
So is the tone happening in EQ?
Yeah, it's analog EQ basically. So this is, I've got some kind of modulation here in this preset, but if I reset to init, so here's the M wave again.
So it sounds like a triangle almost, or a filtered sawtooth.
Here's the live readout here.
Yeah. And there's dirt in it, but it's quite a pleasing dirt.
Yeah, it's kind of unpredictable dirt because the waveform tends to change and interact. The waveforms between individual notes tend to change and interact with each other because there is a certain amount of kind of unpredictability and non-linearity like between those.
Interesting. But you've got a filter. Is that an analog filter there as well?
So yeah, the filter section is there's separate analog multimode filters for both voices.
Right.
So just quickly, I don't know if we mentioned this, but there's 8 electromotors.
Yeah.
And 2 motor voices labeled voice 1 and voice 2. And we've just looked at the M wave, but I'll explain the other waves later on. But the basic idea is that 8 motors give us 4-note polyphony for 2 voices.
Right.
I can also, of course, set the synth into like unison mode, which you know makes all the motors spin together.
So they sync together.
Yeah. So now let's hear, like, we can hear one voice. So now it's in unison mode. Yeah.
That sounds quite precise. Is there any detune? Can you detune it?
Yeah, so well, I can actually just detune the whole keypad. I can detune the voice itself. I can just apply a musical detune effect on the whole synth. So this is the oscillator drift effect, which is really cool in the unison setting.
Oh, that's nice.
So here, if you look closely at the motors, like, right, as I start increasing the oscillator drift, you will see
there's beating, yeah.
There's beating. Like,
because you've got sort of like stroboscopic displays on the top.
Yeah, it's kind of the one, it's borrowed from that system that you use for vinyl calibration. So it's just kind of, see, now we're perfectly in tune. So the red light is strobing with the frequency of the note being played.
Right.
And that, therefore, as soon as there's a mismatch between the rotation frequency...
I've got to hear that down an octave. What does that sound like even lower?
That's 2 octaves down. So the cool thing about the motors is that they can go as low as you want them. Whereas, like, you could say that's the only advantage over standard oscillators.
They could go infrasonic easily, can't they?
Yeah, I mean, you can go as low as you like. Because, you know, until the motors just...
And they look so pretty. They look so pretty when they go...
So, actually we
Wow.
So now we're at E0, you know, and I guess that's as low as they go. Yeah, and then we can go back up. We can also record that.
Oh wow! Okay, so the sequence are built.
Yeah, but we can show that later.
Yeah.
Basically, the reason why I was eager to show the record function and all these like long pitch shifts is because this is kind of one of the most fun things about the synthesizer is basing your performance on these detuning movements and pitch glides and so on. So, for example, if I return back to a preset like the one I played in the intro, which is called Film Pad, right? Here I go, right? I'm gonna latch this note, like this chord. Okay, for some reason. Right? So now I can detune each note.
That's nice. Quite unusual.
Because this interface was designed kind of to bring out that shifty quality that the motors like have. Like, yeah, it's not the same as a standard glissando or portamento or slide. It almost feels like that. So, for example, with the motion record, yeah, functionality. Can record those individual glides and so on.
Wow, that's really interesting. I must admit,
So, for example,
I've just got to say now, I've not heard this sound as sweet as this. It's normally in a demo, in the show environment, it's much more, it's
Yeah.
kind of angry sounding. This sounds really delightful.
yeah, I mean, first of all, thank you for saying that. You know, it's very, very strange, but it can be a very gentle sounding synth. So, besides the M waves, both voices offer 3 other wave shapes. So there's the sine, the saw, and the square, which are the classic waveforms, and those are achieved by these special reflective optical discs
Oh,
that
that's
are mounted on top.
Right, so that's the stuff on the top.
Internally, we call them the optical wave shapes. So there's the electromagnetic wave shape, the M symbol, and then the remaining 3 wave shapes are produced in a very interesting, clever way that you could say that we kind of developed. But basically, what happens is like if I just put the synth into sleep mode or something. So here we have a little thing that's kind of just stops them from idling, and you can see the parking brake on the screen. So these discs here that you see are mounted on top of each motor shaft, and they're made from a reflective material. And the reflective material is covered in a specific pattern that absorbs, like the dark coloration on these discs. Absorbs light, whereas the reflective material, the aluminum, it reflects light.
Yeah.
So, for example, on the underside of each disc, there are 3 kind of circular tracks, let's call them.
Right.
And each one of them is a circular graphical representation of the according waveform. So, for example, the square wave shape would be, it's the middle groove on the underside of these discs.
Okay.
And it's a segment, kind of circular kind of layout of segments
So
that go from
something.
dark to reflective, dark to reflective, dark to reflective.
So it's like
And as the discs are spinning, they're passing over a set of infrared like optical emitters and receivers. So basically, the infrared light gets either reflected by the disc's reflective surface,
a waveform, right? So,
or it gets absorbed. But from the point of view of the infrared, like signal receiver, it's binary, signal is on, off, on, off, on, off. It's not exactly binary because it's gradual, but so for example, to create the sine wave, the outer track of the disc follows like a gradient pattern from being fully reflective to being fully absorbent. And then the result is that, like, if I solo just one of the motors, one of the voices, and I set it to a sine wave, right, we can see the readout here. This is the...
But it's still based on the speed of the motor as well, so...
That is what controls the pitch, because that's the pitch information is the amount of revolutions it makes per second.
Yeah.
So here, one full revolution cycle for each motor equals 7 Hertz. So as I was telling you, I think earlier, if you want to play 700 Hertz tone, then you would have to spin the motors at
100.
At 100, yeah.
Right.
So
We should point out the effects you're hearing are coming from the light pedal as well, so which is
Yeah.
the spring.
that's another thing that is using the optical
Yeah.
technology. So here, for example, the second one we just heard, that was the optical the optical sawtooth wave. Yeah. So this note here. So sine, saw, and then this is the square.
Right.
And then, of course, it's not perfect, but it's as close as you can get with this particular.
There's a sort of chaotic undercurrent, which
Yeah.
is very pleasing. And it's like almost like a super low harmonic.
Yes, you're right. Like there is a certain like kind of unpredictable, unexplainable. There's something going on here. It's a fascinating system, and like we've been listening to these sounds for years now during development, and yeah, it's always like this kind of the magic is there. I can testify.
It's
to that.
so what's interesting about this, you may not or may not be able to pick this up in the room, but obviously there's, when you take the volume down, there is actually physical noise as well, which is quite unusual, because these things are spinning at a certain speed and they move air. And that's another, so it feels quite alive.
It is very much alive. So actually right now, for example, we have the synth in poly mode for this preset. When I changed the preset, it went back into polyphonic. So now I can set it to like Unison mode, and we can start up.
I turned it down.
We can start. That's fine. We can start up a fast arpeggiator, for example, and we can just actually feel the synth kind of shaking a little bit. Let me see. Okay. So, for example, arp. Right? So now, this is the highest octave, so that's why it's really loud right now, but I'm intentionally trying to show you how loud it can go acoustically. So now, when everything is in unison
Sounds like
mode...
a printer, old school dot matrix.
So when everything's in unison mode, every note change, actually all four motors need to kind of do that.
It's interesting. So, okay, let's just let's hold that thought. I mean, what's interesting is going on here. That's fairly fast tracking. I mean, it's a kind of quick. It's not what I would expect from something where you'd expect motors to be spinning, but it's a testament to how quickly those motors respond. Okay, so tell me a little bit about the filter. So the filter, did you say earlier it was based on Eastern Bloc technology? Is it what kind of filters have we got on the voices?
So okay, so these filters are produced by the Alpha chip factory. So basically, it's a Polyvox inspired multimode filter for each one of the for both motor voices. So the very interesting thing about the motor synth in general, it's not exactly bitimbral, but you have full independent control over each one of the motor voices' amplitude envelope, portamento section, which here we call acceleration and brake.
All right, so that's the speed with which it moves between the motor.
Yeah, you can say, for example, so let me clear like the. Go back to an initial preset. So, for example, let's listen to voice one. So this voice, I'm gonna introduce just a little bit of arpeggiation. So here, voice one can have a standard ADSR envelope, looks like this. And then we can bring in voice two. Voice two can be a higher register voice with a different waveform. And this one can have an AD envelope, like this, or like that, or it can even have a looping AD envelope.
Oh, that's nice.
And there's there's lots of options here, and so it's not exactly a bitimbral kind of situation, but you have full independent control, yeah, of two.
Does that go for the filters as well?
And the same goes for the filters. So, for example, it's a shared control set for the filters, but each voice goes through its own analog multi-mode, Polyvox style filter. So right now, I can change settings for both of them at the same time. I just introduced some drive and now some resonance. And now I can also change the filter, like add some filter envelope. Let's do an AD. Curve for the decay parameter. But we can also edit the filter settings for each voice separately. So for example here, you can just double tap the voice 2 and then offset the frequency of the cut frequency for the second filter, increase drive and resonance, change the filter type to high pass, and then return to voice 1, offset that, make it an all pass, for example, and so on. So, and then you know, another cool thing to remember is that the Mark II Motor Synth also has the added third digital oscillator as well. So here is the DCO. It's got it doesn't have a full set of controls on the front panel like the motor voices do, but it's got you can access all of the same settings through like slight shortcuts. So what the DCO does, it offers it fills in for those functions that the motors and the fixed wave shapes cannot offer, such as pulse width modulation, wave folding, wave shaping, and so on. And also they can be used. The DCO can be used as a noise source.
Right. So that's just with what? That's the third oscillator.
That's the third oscillator, and it also
is that
has
per voice or per
so
just
yeah,
overall?
So it's 3 voices basically.
Okay. So it's a
motor
digital
voice 1, motor voice 2, and then there is the DCO, and all 3 of them can work within a 4-note polyphony range. So, and the cool thing about the DCO is that it also has its own fully independent amp envelope, pitch envelope, filter envelope. It has a digital filter that emulates the analog filter closely, but you can also route it through one, the other, or both analog filters.
So you've got a pretty flexible voice structure there.
Yeah, so you can use the digital voice to kind of enhance the patches. So I guess maybe I could load up a patch that shows all 3 voices.
Yeah, let's have a listen.
I'll start off with blending in one voice at a time. So I'm matching some notes. That's voice 2. Voice 1. And then the digital voice, which is just modulated frequency folding, I think, like wave shaping, wave folding. Yeah, pulse width modulation and folding, which is modulated to create the throaty effect.
It's got a real sort of organic vibe to it. And I can hear there's a lot of drive going on in that.
Okay. Without the drive, it's a bit, of course, it's different. I'll show you another quick.
So this is arpeggiating as well, isn't it?
This is arpeggiating, yeah. So these are arpeggiator type presets. So the presets are organized into 8 banks. Pads, bass sounds, lead sounds. For example, here's the faux piano sound, right? Here's
there's a
harpsichord.
Massively low there, yeah. So I mean, I think it's fair to say, you know, if you're looking for a synth that's going to emulate sort of real-world acoustic instruments, it's probably not the one that you would immediately spring to mind. It's got its own
I
thing.
mean, the name says harpsichord, but in reality, it's, you know, it's just kind of the maybe the idea of the instruments like decay
Yeah,
or
yeah.
something like that. That's what
Of
was
course.
preserved. But so as a, I'll show you this preset here, which is really one of my favorites. This is inspired by Francis Bebey. I think it sounds pretty natural, like a bunch of flutes and stuff.
Yeah.
So this is a really fun preset because you can just like, I don't know how, why, but it happened, and then we refined it, so.
That's nice. So we just hold things there a second.
Sorry?
Just hold fire. So I do notice that there's also some CV control. So this can be played from an external MIDI keyboard, right?
Yeah, sure.
Other control inputs are, is this CV in or CV out? Yeah, so we've got, and those presumably can be mapped via modular system or whatever into other parameters for modulation and...
Yeah, so here you've got this, so the synth is pretty smart. You've got this, we've got this system, for example, like there's 3 freely assignable modulators, which is also something that's new in the Mark II version. So each modulator, as well as each CV input, can be freely mapped to pretty much any parameter on the synth. So now, for example, I've got CV1 right here, and I pressed the encoder, now it says turn knob, so now it's going to be the frequency cutoff for voice 1, and then that's confirmed. And then in the second page I can also attenuate that or attenuvert that CV, and it's quite actually convenient because it's not, you know, you can...
So you build some pretty complex stuff up there, yeah.
So the modulation matrix was like started from here, and then, you know, once we had all the system kind of developed, then we applied the same idea like for the CVs. You can map, we can map things to pretty much anything. So
3 CVs and 3 trig inputs here, right?
Yeah, so there's some of these presets, they exploit the modulation section quite a lot. I hope I can find something that's interesting. This probably is one of them. Right. Something else. But yeah, we can pretty much map each modulator to anything on the synth.
Right, so there's quite a lot of flexibility there. So there was a sequence you showed me earlier that it's possible to record parameter movements and pitch movements and whatnot into a sequence as well?
Yes, so there is a built-in sequencer, and you can, and there's a sequencer, and there's a motion record engine with 8 motion record lanes, and each one of the motion record lanes, so you can record synced to a BPM, you can record them unsynced, or you can record them synced to the pattern length of the currently running sequencer pattern. So there's a lot of options there. Also, the arpeggiator is quite kind of, I don't know, quite advanced. So here's a whole bunch of like ARP type presets. So I'm gonna, for example, load this one. And like in the ARP section here, you can change the obvious stuff, you know, like this.
So beat divisions.
Yeah, beat divisions. So here we can go into ARP rhythm. So like you have on the like these controllers, you can just
just mute certain steps and create custom rhythms.
So I think like that's already cool, like a cool little performance thing to have, because then you know. So that's nice, and then we can do a lot of interesting things here. We can add an accent on every first, like on every first out of 4 steps, do the octave shifts and so on. And also there's a, for example, clutch button, which allows you to make parameter changes and initiate, exactly, drop in a whole bunch of parameters all at once, like changing filter, drive, cross mode, detune, scale, you know, time division of the ARP, 2, 3, 4.
Oh, that's interesting.
Yeah, so there's a lot of, like, we kind of got, the Motor Synth is Gamechanger Audio's first attempt of building a synthesizer.
I mean, you went.
And we went pretty crazy.
You went pretty hard on the kind of wacky ideas and the interesting interface choices and just the way that you've built it. I mean, it's still familiar, but it's also sort of reassuringly different, I suppose, in a weird way. I mean,
I think the real original part is the I would say for me the top kind of originality. Like, never mind the sound engine itself, I would say that the ability to have full control over each voice's amp envelope and glide envelope and like portamento envelope and filter, that's a very, very strong point of the synth. Yeah. Secondly, I really, really enjoy playing with this kind of detune-oriented interface here and the motion record sequencer. So, for example, I'll just load up another sound, maybe that can be our, you know, outro or something like that. But for example, let's do an organ sound.
Yeah, because I mean, I was thinking that this must lend itself to organ because tone wheels.
Exactly, yeah. So for example, here's
in my head anyway.
So for example, here's an organ sound.
And that's quantized snapping to notes on those.
You can, of course, you can change that just to microtonal. And this is where I really, really like synth kind of this design, and together with the motion record engine, like you mentioned. So, for example, we have 8 tracks of motion recording. So maybe we can try and fill them up. So now I've armed the recording engine. Record the filter movement. Now we can record the movement, for example, of this note.
It's nice.
We have that. Now we can do detune effect for the whole synth.
So is this 16-step sequence, or how long is the actual?
So here I'm kind of exploiting the options that are provided by the motion record engine. So now they're all recording freely onto like a time grid, and I can also just like I can mute those lanes, or I can stretch, or I can time stretch those parameter records, kind of like that. So this one's playing 3 times as fast, and yeah, we can change the playback direction of it. For example, we can go back and forth and so on. So you can create a lot of these interesting kind of drones, and now let's go to the octave. Yeah,
that got crazy pretty fast, yeah.
Yeah, so that's the motion record engine is something that's quite interesting about the synth. The separate the level of control, and you know, the modulation section, ARP section. So those are the cool things. And also there's the input as well, which allows you to use external audio or a trigger to either move the arpeggiator forward or for example, you can use external audio to produce a ducking or gated
Right, so you've
kind
got
of
a more
compression.
another
compression
modulation.
effect.
So right, okay.
So for example, we can take this drone that we've built, like something that's just like a layer of sound, and we can send in an external like kick or percussive element to kind of create a ducking envelope.
Accents or additional.
Yeah. We can also use the motors, the signal produced by the motor as a like in a strange kind of motor vocoder setup. It's a limited vocoder that uses the motor signal as the modulator and the incoming audio as the carrier signal.
Right. So this is now shipping again. You're selling again. What are you selling it directly, or is it going via retailers? Or?
It's available with multiple, like it's available both directly and through our dealers. Yeah, the synth is $32.99.
Right.
Which is a kind of a expensive price tag, but it is.
I mean,
it's a polyphonic analog electromechanical synthesizer, and I think we've built this synthesizer for some, probably it's not the entry level synth. It's quite complicated and quite feature
rich, but it's
rich.
I haven't heard anything that sounds like this. That's the other thing.
Yeah, it's from our point of view, it's that like if you already have, for example, like a decent, big, proper analog synth, maybe this is the next instrument that will inspire you or make you curious about what you can do with it. So from our point of view, it's also the most rock and roll synthesizer that's ever made, because it's actual electromagnetic coils spinning and producing energy.
That's a great way to put it.
So yeah, that's kind of our philosophy. Like, it's engineering point of view, kind of also this kind of, it's alive feeling.
It's alive.
And
Ilya, thank you so much. Thank you so much for letting us know about the Motor Synth Mark II. I guess you're going to play out. We'll have a bit more music to play out with. But thank you very much for watching. That was Sonic Lab.